Hello, I'm Allison, and this video is brought to you by the Math and Science Learning Center as part of the Quantitative Methods lecture series. In this video, I will be going over the elements of a linear programming sensitivity report in Excel. So the reason we care about this report is because of an aspect of business analytics known as sensitivity analysis. So when we're creating a mathematical model, we create it under certain conditions or with certain parameters. And what sensitivity analysis helps us do is determine how changing those parameters will affect our optimal solution. So we also call it what-if analysis because we're asking questions like, what if I change my objective coefficients? Or what if I change my constraints? How is that going to affect my final solution or the final profit or cost within my, whatever the context is? So our report that we get from Excel is going to help us answer these types of questions. So let's use our sensitivity report from a previous example in a different video. In this example, we had a farmer who was planting acres of corn and acres of green beans on 12 acres of land. She had to plant at least 6 acres worth of crops, and she had $1,500 to do it. Each acre of corn cost $200, each acre of green beans cost $100, and she was going to have to plant it all in 12 hours, with an acre of corn taking 1 hour to plant and an acre of green beans taking 2 hours. She had the possibility of earning $450 per acre of corn and $350 per acre of green beans in profits, and our goal with this problem was to determine how many acres of each she should plant to maximize profits. So, in the previous video, we determined, using Excel, that she should plant 6 acres of corn, 3 acres of green beans, and that her profits would be $3,750. And when we found that in Excel, we were also able to choose a sensitivity report that looked like this. So you'll notice it's split into 2 sections. We have our variable cells and our constraints. Our variable cells just really talk about the objective function, and our constraints are all of the conditions of the problem. So it gives us her acreage max and acreage min, her budget, as well as her time. So these were all of her resources that we were looking at in this problem. So the first thing we can see very clearly with both of these sections is that it outlines the givens of our problem, right? We know that for our objective, we are looking to maximize profit. So the profit that we could potentially make from corn was $450 per acre, and for green beans, it's $350 per acre. For the constraints, we see all of our conditions that we were given. So we know that she only had 12 acres of land. She had to use at least 6 of them. She had a budget of $1,500, and she had 12 hours to do all of her planting. Okay, so it's all clearly laid out for us in this table. The other thing that's really clearly laid out for us is our final solution. So we know that in the end, she needs to plant 6 acres of corn, 3 acres of green beans. And then we're told how much of each resource she actually used. So we know that she used 9 acres rather than her full 12. She used all $1,500 and all of her time, her 12 hours. So just based on these 2 columns alone, we could determine the profit if we weren't sure what the optimal solution is. So I could take my final values for my variable cells and my objective coefficient and multiply those and add them together. So I could take my 6 acres of corn and multiply them by the $450 that I would make on each of them. And I could add that to the amount that I'm making from my green beans, which is 3 for the 3 acres times 350. And when I add that up, I would find that my maximum profit is $3,750. So from this point forward, with the rest of our columns, I'm going to split it up into the 2 different sections because the columns mean a little bit different things for our variable cells and our constraints. So we're going to tackle the objective function or the variable cells section first. When we see this allowable increase and allowable decrease section, what we're talking about is the sensitivity range for objective coefficients. What this tells us is how much I can increase or decrease my objective coefficients without actually changing the final solution. So I can make changes to my profit without actually changing the fact that I'm going to plant 6 acres of corn and 3 acres of green beans. For instance, let's say I take my corn. I know that I had planned on, or our farmer had planned on making $450 in profit for each acre of corn. But what this allowable increase tells me is that I can actually add $250 to that and really have a possibility of earning $700 in profit per acre of corn without it affecting my final solution. Again, this will impact my profits and potentially earn me more, assuming that I'm able to sell all of that corn, but it won't affect the fact that our farmer should plant 6 acres of corn and 3 acres of green beans. On the flip side, our farmer could also charge less per acre of corn, and maybe she's deciding to decrease her profits for some reason or another. Maybe she needs to lower the price so more people will buy, and if that's the case, she can drop the price down to $175 per acre of corn. Again, still maintaining the fact that she will plant 6 acres of corn and 3 acres of green beans. We could do the same thing for green beans. One thing to keep in mind is that we make these changes independently of each other. So it's not guaranteed that if you make changes to the corn objective coefficient and the green beans objective coefficient together, that it will still maintain the same optimal solution. When we look at these sensitivity ranges, it's simply talking about the individual variable. Right, we also have information about reduced cost, also known as opportunity cost. In a situation where we have a variable that has a final value of 0, our opportunity cost tells us how much producing 1 unit of that variable will change our objective function, in this case our profit. So let's consider a different scenario. Let's say that we actually had carrots involved in this model, that our farmer had decided to include carrots in her yields that year. So let's assume that we get this extra line in our sensitivity report on carrots, right, with a final value of 0 and a reduced cost of -100. What that -100 means is that if she absolutely has to produce 1 acre of carrots, she's actually going to lose $100 on her ultimate profit. Yeah? So we found previously that her optimum profit was $3,750. That means that if she added 1 acre of carrots to this model, she would actually be dropping down her profits to $3,650 for each acre she increased it by. Okay, you'll notice that this reduced cost is the same magnitude as our allowable increase. That is going to be the case when we're talking about a problem with maximizing profit. If we were talking about minimizing cost, the reduced cost would be equal to our allowable decrease. So we have some similar columns when we look at our constraints. So we can also find a sensitivity range for the right-hand side of our constraint values. So very similarly to our objective coefficient sensitivity range, this allowable increase and allowable decrease gives the range of values that are allowed for the constraint's right-hand side without changing the solution variable mix. So unlike our objective coefficient sensitivity range, when we make increases and decreases to our resources, it has the potential to change our solution. However, the variable mix, meaning which variables we choose to produce, will not change. So if we think back to our variable slide, we are producing acres of corn and green beans, and that will not change even if we decide to add $900 to the budget or take away $900 of the budget. We might end up producing different acreage, We might produce more acres, or we might change the ratio of corn to green bean acreage, but we are still going to just be producing corn and green beans. If we say had carrots in the model, they wouldn't suddenly be added in, because that would change our solution variable mix. So, just to reiterate, when we make changes to the constraint right-hand side, and we either add or subtract away resources, it has the potential to change our solution, but it won't actually change the things that we are producing. The times that it will change our solution is when we have a binding constraint. So a binding constraint is something where we're already using up all of the resource, in this case our budget and our time. If we happen to add more acreage, then it's not really going to affect our model. Right, so lastly, our last column is our shadow price. This is also called dual value. We also think of it as being the marginal value of one additional resource, or one unit of a resource. So shadow price tells us how much we are going to change our objective if we add 1 unit of a certain resource. So in our case, let's say we use or look at our time usage. What this 83.33 continued tells me is that if I decide, or if our farmer decides to add 1 hour, she has the potential to earn $83.33 more in profit, just by adding 1 hour of extra time. Or we can also think of this with the question, how much would you be willing to pay for 1 more hour of time? Yeah? At the most, our farmer should pay $83.33 to get an extra hour, because that's as much as she can possibly add to her profit using that resource. Now, one thing that's important to know about shadow price is that this only applies within the sensitivity range. So, I could add up to 9 hours to my resources, right? We could end up having 21 hours worth of time, and for each of those additional 9 hours, our farmer has the potential to earn $83.33 more for each of them. But let's say she decided to add 10 extra hours of time, our shadow price is going to change. Yeah, so we can't guarantee after adding 10 hours worth of time that we'll actually be able to earn $83.33 on each additional hour. So, these are all of the pieces of our sensitivity report in Excel. Hopefully, this helps you in better understanding the sensitivity report and sensitivity analysis in general. If you still have questions, please feel free to stop by the Math and Science Learning Center, and a tutor will be able to help you there.